Hello, welcome to section 3.3. We're going to talk about literal and linear equations. So literal equations are when we have a lot of variables going on. Linear equations you've already seen before in slope-intercept form, which, just to refresh your memory, slope-intercept form was y equals mx plus b, where m was the slope of a line and b represented our y-intercept. And then we talked about standard form, ax plus by equals c, where a, b, and c are numbers, x and y are your variables just like they were up here, and a and b were your coefficients, which means they're the number in front of the variable, and c was a constant. So what we're going to do in, this is a very short video, what we're going to do in each of these sets of problems is convert your equations from one form into the other. So these equations are in standard form. I want to get them into slope-intercept form, aka you just want to get y by itself and you want to get the other stuff on the other side of the equal sign. So they're going to follow kind of a similar format. Whenever you're trying to get something into standard form, you want to get the y part by itself, which means you need to take this whole part right here and bring it to the other side. So notice how this is a negative 4x. What you're going to do to bring it over is just add 4x to both sides. If you think about it, if you took negative 4x and you added 4x, it would go away, and I'm left with 9y equals positive 4x plus 45. And notice how I also wrote the part with the x first before the constant 45, and that's because of y equals mx plus b. So still don't have y by itself. The next part is crucial. You need to divide by 9, but you need to do it from everything. You need to do it from right here, you need to do it right here, and you need to do it in the third part by the constant term. So what you end up with then is y equals 4 over 9x plus 45 divided by 9, which is 5. So if you can simplify this fraction, I encourage you to do so. 4 over 9 is already in simplest form, but what this means is that your slope is 4 over 9 and your y-intercept is positive 5. In the next example, so that's it. Next example, we're going to do the same thing, but notice now I have a positive 6x. So we need to bring that to the other side by subtracting it first then. So 6x minus 6x means that's going to go away. Be very careful, you're bringing down the negative 2y. Write the x part first. Notice it's negative 6x, and that's a minus 52. So you need to bring that down. And now let's take a look at what we have here. I need to divide everything to get y by itself. I need to divide everything by negative 2, not just 2, but by negative 2. And there's a lot of negatives here, so let's watch our signs. Y equals, I have negative 6 divided by negative 2, which is positive 3, so 3x. Negative divided by negative, 52 divided by 2 is 26. So at the very end of this, what that means is that my slope is 3, or you could even write it as 3 over 1. And my y-intercept is 26. So they seem like very short problems. The point of converting things is it's a lot easier to graph sometimes when something is in slope-intercept form. So this might be a thing that you would want to do. If you have an equation in standard form and you wanted to graph a line to see it, you could convert it into slope-intercept form. There will be times, though, where, like what we did in section 3.2, we use intercepts from standard form to solve. And we might be doing that too. We talked about like the hamburger and hot dog problems where you're selling one quantity and not the other. And what you can do in that case is find intercepts and then graph. So what we're doing in this section is just the conversion. So then I have 3 examples at the end here. What we're going to do is convert these from slope-intercept into standard form, which is the ax plus by equals c. So what you want here are for a, b, and c to be whole numbers. I'm actually pretty sure it only has to be a and b, but I'm going to make sure that all 3 are going to be whole numbers, which means for this first problem we're not going to have an issue, but for these I have fractions with my x values because the slope is a fraction, so we'll get rid of that later, and that won't really be much of an issue. So what we need to do, the easy way of me explaining what standard form is, let's get x and y on the same side of the equal sign. So I want to move this negative 5x over to the other side, and I want to leave the negative 13 right where it is. So how do you get rid of a negative 5x? Well, you add 5x. So I'm going to do that to both sides. And since standard form has your x part before the y, I'm going to write this as 5x plus y equals negative 13. Believe it or not, that is all you have to do. We are in standard form. My x and y are on the same side of the equal sign, and they are whole numbers. For the next one, what I'm going to have to do first is get my x and y on the same side. I'm going to need to bring over this positive 2 over 3x by subtracting 2 over 3x on both sides. So on your left side, I have negative 2/3 x plus y equals negative 6. Now, I have a fraction for my x. I don't like a fraction. So the easiest way that I'm going to be able to get a whole number for this is I need to get rid of this 3 on the bottom somehow. How I'm going to do that, my denominator is 3, is I'm going to multiply a 3 here, a 3 here, and a 3 here. And watch what happens. When you take 3 times negative 2 over 3, this 3 here is going to cancel with the 1 on the bottom, and you're going to be left with negative 2x. So this 3 actually cancels with the denominator. That's why I multiplied by 3 in the first place, is I need something to cancel out with that denominator. But you cannot forget to multiply it by everything else. 3 times y is 3y, and 3 times negative 6 is negative 18. So we got rid of our fraction. It's the same exact equation. You could even put this back into slope-intercept form if you don't believe me, but you would get the same exact equation as what we started with. But getting rid of that fraction is important for standard form. So then we'll move on to the last example. What you want to do first here, since I have a negative 1/2 x, is you want to add the 1/2 x to both sides. So I end up with 1/2 x plus y equals negative 3. Don't forget the negative. And again, we have a fraction. I don't like the fraction, so let's get rid of it. I'm going to do that by multiplying by what my denominator is here, by 2. And you're going to do that across all three of these terms. So 2 times a half, well, if you have 2 halves, you have 1 whole, so that's x, plus 2 times y is 2y, and 2 times negative 3 is negative 6. So what you end up with then is an equation where your x and y are on the same side of the equal sign. They are not fractions, and we put our equation from slope-intercept form into standard form. And the ones that we did this were just vice versa.